Today we're going to talk about something called reference angles. And reference angles are something you can use to help you figure out the sine or cosine values of a trig function that's on the unit circle. So a reference angle is the positive angle formed by the terminal side of the angle theta and the x-axis. Reference angles relate the given angle to its corresponding angle in the first quadrant. So, looking back at the unit circle up here, we talked about how we have some symmetry, how we have maybe 30 degrees right here and 150 degrees, and how those two angles have the same sine and cosine values, just the sign is different. So what the reference angles allow you to do is to get your first quadrant angle, so 30 degrees, and then change the signs of your coordinates based on what quadrant theta is in. So for example, if you know that the reference angle for 210 degrees is 30 degrees, well, then you only need to really memorize these coordinates and then realize that, okay, 210 degrees is in quadrant 3, so it's going to be these coordinates up here, just with both coordinates as negative. Let's go back down here. So this reference angle is just the angle to the closest x-axis. So in quadrant number 2, you would take 180 and subtract theta, and that's how you would get your reference angle, because 180 is a full circle. And if you subtract the angle from here, you get the reference angle to the nearest x-axis. And in radians, it'd be pi minus theta. In quadrant number 2, you would take your angle and subtract 180 from it. So it's almost the same thing as quadrant 2 over here, just reversed. So you would take your angle, and it goes all the way around, subtract half a circle, and you're left with that angle to the nearest x-axis. And then in quadrant number 4, you're doing a full circle minus the angle you're given, and then you're left with just the angle from the terminal side to the nearest x-axis. So if we look down here, we're going to sketch the angle, then find the corresponding reference angle for theta. So negative 150. Remember, negative degrees go clockwise. So negative 165 is almost negative 180. So it's going to be close to our x-axis, and it's going to go this way. This will be theta. Now the reference angle, we're trying to figure out what is this measure right here to get from our terminal side to the nearest x-axis. So what we can do is say, okay, well, it was a full circle, a full half circle, and then we can add this negative angle. So 180 minus 165, and that's 15. So this little angle right here is 15 degrees. Now 7 pi over 4, well, 7 pi over 4 is almost 2 pi over 4, which is almost a full circle. And since it's a denominator 4, we know that goes with 45 degrees, a multiple of 45 degrees. And it is in quadrant number 4. So this will be your angle. Then your reference angle, since we are in quadrant 4, we're going to do 2 pi minus 7 pi over 4. Now, you're going to get good enough at some point where you don't need to do this subtraction. You will be able to realize, oh, okay, it's a 7 pi over 4, which means this angle right here has got to be 1 pi over 4. But you can always do the math just to verify. So pi over 4 is your reference angle. Now, 150 degrees. Well, we know 150 degrees is in quadrant number 2, and it's close to 180. So this will be your angle going in this direction because it's positive. And we're trying to find out what this angle is. And again, you may be able to look at this and say, oh, okay, I am 30 degrees away from 180, which is your x-axis right here. You could do that, or you can do 180 minus 150 and get 30 degrees. And the last one, 5 pi over 3. And 5 pi over 3 is in quadrant number 4. Well, here's our initial side. And we're going in this direction. So we're going to do 2 pi, which is 6 pi over 3. So 6 pi over 3 minus 5 pi over 3. So our reference angle is pi over 3. So again, what that allows you to do is say, I know what the sine and cosine values of pi over 3 are, and then I can just translate that to find out what the sine and cosine values of 5 pi over 3 are, and then change the signs. All right, on the next page, this little chart right here tells you the signs of our 6 trig functions depending on the quadrant. I don't really think it's useful to memorize this. I think it's more useful to remember that this is a coordinate plane with your origin at 0, 0. So if you have a point over here, forget the sine cosine stuff. If you have a coordinate point right here, you know the x coordinate is negative and the y coordinate is positive. Similarly, if you have a point down here, the x coordinate is positive and the y coordinate is negative, then we can translate that to sine and cosine values, which then allows us to get the other 6 trig, the other trig functions. So I think memorizing that would be a poor use of brain real estate. All right, down here, we're going to use these steps to evaluate a trig function of any angle. So first, we're going to find the reference angle for theta, then evaluate the trig functions for that angle, and then determine the sign of the trigonometric values from the quadrant in which theta lies. So cosine of negative 225 degrees. So because it ends in a 5, we know that it is a multiple of 45, which means our reference angle is 45 degrees. All right, so the cosine of 45 degrees is a square root of 2 over 2. But now we have to figure out what quadrant we are in. We can always take our angle and add or subtract a circle. So I do that and I get 135. Well, 135 degrees is in quadrant number 2, where the x coordinates are negative and x values go with cosine. So the value of cosine of negative 225 degrees is negative square root of 2 over 2. Now, cotangent of pi over 3. I think it's actually easier for radians to know the reference angle because your denominator will always tell you what your reference angle is. So your reference angle is pi over 3. Okay, so now we have to figure out what the cotangent of pi over 3 is. Well, cotangent, remember, is the cosine over sine. The cosine of pi over 3 is 1/2, and the sine is the square root of 3 over 2. Well, we then have to multiply by the reciprocal. The 2's cancel, so we have 1 over the square root of 3. which you guys are getting good at rationalizing this without having to show all the work. Multiply the top and bottom by the square root of 3. So we get the square root of 3 over 3. Now we have to figure out what quadrant we are in. So 10 pi over 3. If I do 10 pi over 3 minus 6 pi over 3, which is one full circle, I get 4 pi over 3, which we know is in quadrant number 3. And in quadrant number 3, sine and cosine are both negative, which makes tangent and cotangent positive. So our answer here is the positive square root of 3 over 3. Right, then we have the secant of 300 degrees. The reference angle is 60 degrees because if we do it, I'll do it up here. 300 degrees is in quadrant number 4. So we have to do 360 minus theta, which is 60 degrees. So secant is 1 over cosine. So 1 over the cosine of 60 degrees, which equals 1 over 1/2. We get 2. Now we have to figure out it at 300 degrees, is cosine positive or negative? Well, quadrant number 4, cosine is positive. So that means our final answer is just going to be 2. Your sine of 17 pi over 6. Our reference angle, again, is going to be pi over 6. Well, the sine of pi over 6 is 1/2. So now we have to figure out what quadrant our angle is in. So we're going to do 17 pi over 6 minus 2 pi, which 2 pi is 12 pi over 6. And that gives us 5 pi over 6. Well, 5 pi over 6 is in quadrant number 2, where sine is positive. So our answer is just going to be 1/2. All right, I want you to try these two problems, and when you're done, unpause the video, and you can see if we get the same answer. All right, so here are your answers in the work. So for the tangent of negative 240 degrees, what we just did is sine over cosine, and the reference angle would be 60 degrees, and that's simplified to the square root of 3, but we have to figure out that negative 240 degrees is in quadrant number 2, and in quadrant number 2, tangent is negative, so that's why it is negative square root of 3. All right, now the last one here, cosecant of negative 15 pi over 4. We said reference angle is going to be pi over 4. So 1 over the sine of pi over 4 will simplify all the way down to the square root of 2. Because once you multiply by the reciprocal, you then have to multiply the top and bottom by the square root of 2, which will then equal this. And that simplifies to the square root of 2. And then in the red and the blue, I added 8 pi over 4, which is a full circle, until I got an angle that is positive that I can figure out on the unit circle. So that gives you the square root of 2. Because sine is positive in that quadrant. So that's why it says positive. All right, we are going to skip example 3, so that's it for our video. Thanks for watching. Make sure to like and subscribe.